And so we are left with this broken cosmic ledger, a profound imbalance at the heart of reality. The laws of physics, in their pristine mathematical beauty, demanded a perfect symmetry at the dawn of time, an equal creation of matter and its ethereal twin antimatter. Yet as we gaze out from our lonely outpost, we see only the debris of one side of that equation. We see a universe of substance, of rock and gas and water, a cosmos built from the protons and electrons we know so well. The ghost particle, the antiparticle, is nowhere to be found save for fleeting violent apparitions in our most powerful laboratories. For every billion particles of matter, only a scarred and desolate emptiness remains where a billion antiparticles should be. This is the universe's great unsolved crime scene. The evidence has been wiped clean, the culprit has vanished, and we, the descendants of the sole survivor, are left to sift through the ashes, asking the most fundamental question: where did everything go? The search for an answer has pushed us to the very edge of reason, forcing us to confront a possibility so radical, so contrary to our deepest intuitions, that it feels more like mysticism than science. What if the universe never broke its promise of symmetry at all? What if the balance was never lost but merely hidden from our view? The solution may lie not in searching for a flaw in the cosmic code, but in realizing we have only been reading half of it. The key is a sacred principle in physics, an idea of such profound elegance it is considered the most fundamental symmetry of all CPT. 3 letters, each representing a transformation that could be applied to our universe. C for charge is the act of swapping every particle with its antiparticle, turning our world of matter into one of antimatter. P for parity is the reflection in a mirror, swapping left for right, turning every spin and every motion into its reverse image. And T for time, the most unsettling of all, is the reversal of its arrow, making every process run backward from a shattered glass reassembling itself to a star collapsing back into a cloud of pristine gas. We have discovered to our astonishment that nature does not respect each of these symmetries individually. The weak nuclear force which governs radioactive decay shamelessly violates parity. It can tell the difference between left and right. It also violates charge symmetry. But the combination, the grand trinity of CPT, is believed to be inviolable. It is the universe's ultimate failsafe, the one mirror it cannot help but look into and see a perfect reflection. This principle, this unbreakable triad, suggests something truly staggering. If you were to perform all 3 transformations on our universe, flip every charge, reflect it in a mirror, and reverse the flow of time, the resulting cosmos must be absolutely identical in its physical laws to our own. It would be a perfectly valid, functioning universe. This has long been a beautiful abstract concept for physicists. But now a bold and breathtaking hypothesis is gaining ground, suggesting this isn't just a mathematical trick. It is a description of reality. It proposes that the Big Bang was not a singular event, but a moment of profound bifurcation. Imagine it not as an explosion in space-time, but an explosion of space-time. A single point that blossomed in 2 opposite directions at once. At the moment of creation time, 2 universes were born, springing forth from a common origin, like the head and tail of a single coin, forever linked, forever separate. Our universe, the one we inhabit, was flung forward along the river of time, and through some primordial quirk it developed a slight preference for matter. But to preserve the sacred CPT symmetry, to keep the cosmic books perfectly balanced, another universe must have been created simultaneously, a universe that from our perspective was flung backward in time. And this mirror cosmos, to complete the reflection, would have the opposite charge. It would be a universe dominated not by matter, but by antimatter. This is a vision of creation on a scale that humbles all mythology. It is the universe as a cosmic Janus, the two-faced god, looking into the past and the future at the very same instant. From the singularity, 2 rivers of causality began to flow, carving their paths through eternity in opposite directions. For the inhabitants of that other cosmos, their Big Bang is also in their past just as ours is. Their time flows forward towards their own future, with the same inexorable sense of passage that we feel. But their forward is our backward. If we could somehow stand outside of space-time and watch the whole magnificent spectacle unfold, we would see two expanding spheres of reality blossoming from a single point of origin, their temporal arrows pointed in opposite directions. It is a conception of such perfect, breathtaking symmetry that it feels almost inevitable. It solves the universe's greatest mystery not by finding a missing piece, but by revealing that our puzzle is only half of a much larger, perfectly assembled whole. The missing antimatter was never missing at all. It simply populates the other side of the cosmic mirror, the sibling universe born to balance our own. It is the yin to our yang, the shadow to our light, ensuring that from the perspective of eternity, the net sum of all creation was and always will be absolute zero. Let your imagination travel there across that temporal divide. Picture a world governed by the very same laws of electromagnetism, the same principles of gravity, the same quantum mechanics that shape our reality. The only difference is that every fundamental charge is reversed, in that cosmos stars are not balls of incandescent hydrogen, but of antihydrogen. They would burn with the same ferocious intensity, fusing antiprotons and antineutrons into anti-helium-releasing photons that are indistinguishable from our own. From a distance, their sky would look identical. Great spiraling galaxies of anti-stars would paint the velvet blackness, their light travelling for billions of years to reach the lens of a telescope. Planets forged from the ashes of these anti-suns would be made of anti-elements, anti-iron, anti-silicon, anti-carbon. They would have mountains of anti-rock, oceans of anti-water, and atmospheres of anti-nitrogen and anti-oxygen. The chemistry that unfolds there would be a perfect mirror of our own. Anti-water would still be a polar molecule, an excellent solvent. Anti-carbon would still form the long complex chains necessary for life. There is absolutely no reason, no physical law that would prevent the emergence of biology in such a place. Imagine then a being on such a world. An anti-human composed of antiprotons, antineutrons and positrons. Every atom in their body would be a reversed image of yours. They would feel the warmth of their anti-sun on their anti-skin. They would breathe in the crisp anti-air after a shower of anti-rain. To them all of this would be perfectly normal, mundane, real. They would not feel reversed or strange any more than a person in Australia feels upside down. Their scientists, their astronomers, their physicists would look out into their cosmos and be confronted with the exact same mystery that we are. They would measure the cosmic microwave background radiation, trace the expansion of their universe back to its origin, and be utterly baffled by a profound and inexplicable imbalance. Where, they would ask their minds, reeling from the cosmic injustice of it all, did all the matter go? Their equations would scream for symmetry, for a universe born of equal parts, yet their telescopes would show them only a sea of antimatter. They would write papers, hold conferences, and dream of a lost world made of the exotic elusive particles of matter. They would be searching for us just as we are searching for them. This realization is one of the most profound paradigm shifts in the history of thought. It recasts humanity and our entire observable universe from being the sole product of creation into one of two equal partners in a cosmic dance. We are not a statistical fluke, a lucky remnant in a war of annihilation. We are a necessity. Our existence, our universe of matter, is required by the laws of physics to balance the books. We are the other half of the equation. We are the reflection in the mirror. But if this other universe exists, this temporal twin, where is it? It is not in some distant corner of our own cosmos beyond the reach of our telescopes. The theory suggests it is far closer and yet infinitely farther away than that. It coexists with us, occupying the very same space-time but moving on an opposing current of time. We are like two ships sailing on the same ocean but in opposite directions, forever sharing the same water but never able to meet. We are fundamentally causally disconnected. The iron wall of time's arrow separates us. Any attempt to send a signal, a message in a bottle across the temporal sea would be futile. It would be like shouting into a hurricane, the sound torn away before it could ever reach its destination. For them to receive a message from us, it would have to travel backward in their time arriving before it was sent a violation of causality that their universe, just like ours, would not permit. And yet is the separation truly absolute, while matter and antimatter would annihilate upon contact and we cannot exchange information using light. There may be a subtle ghostly thread that connects our two realities. One force and one force alone is indifferent to charge. Gravity. Gravity is the universal language, the one force that speaks to all forms of mass and energy, matter and antimatter alike. It is purely attractive. An anti-apple would fall onto an anti-Earth with the exact same acceleration as our apples do, and most tantalizingly, an anti-galaxy would pull on our galaxy with the same gravitational embrace as any other. This opens a door just a crack to a truly mind-bending possibility. For decades, we have been haunted by another cosmic phantom, dark matter. It is an invisible substance, a hidden architecture of mass that holds our galaxies together, preventing them from flying apart. We can feel its gravitational pull, we can map its ghostly presence, but it does not interact with light. It is utterly stubbornly dark. What if dark matter is not some new, exotic particle from our own universe? What if it is the first faint whisper from the other side? What if dark matter is simply the ordinary matter? The stars, planets, and gas of the anti-universe, its gravitational influence bleeding across the temporal divide, a ghostly hand reaching out from the mirror world to steady the spin of our own. This idea would elegantly solve two of the most profound mysteries in cosmology at once: the absence of antimatter and the presence of dark matter. The mirror universe is not just a mathematical curiosity. It becomes a physical necessity, its gravitational shadow cast across our own cosmos. Furthermore, there might be another messenger, a particle so strange and ethereal, it barely seems to belong to our world at all. The neutrino. These tiny, nearly massless particles are produced in abundance in the hearts of stars. They are the ultimate cosmic nomads, barely interacting with matter at all, able to pass through planets, stars and entire galaxies as if they were empty space. Some theories suggest that certain types of neutrinos, known as Majorana neutrinos, could be their own antiparticles. They might be the one entity capable of acting as a bridge, a tiny pinhole in the fabric of spacetime that could allow for some form of leakage or oscillation between the two universes. Could the strange behavior of neutrinos in our particle accelerators be a hint, a subtle sign that they are feeling the influence of their counterparts from a world running on an opposite clock? Are they the faint crackling signals from a ship we can never see, proof that we're not alone on this cosmic ocean? The implications are almost too vast to hold in our minds. It would mean that every star you see in the night sky has a corresponding anti-star, every galaxy a twin anti-galaxy, every black hole a mirror image, an anti-black hole that from our perspective would look like a white hole spewing matter and energy out from a singularity. And somewhere in that cosmos, moving backward from our point of view, a being made of antimatter might be looking up at their night sky, seeing the faint gravitational evidence of our galaxy, and wondering if within that ghostly glow, a counterpart to their own consciousness is looking back. This is not just a theory about matter. It's a theory about who we are. It reframes our place in the cosmos from a position of lonely solitude to one of profound unseen partnership. We are no longer the improbable survivors of a cataclysm, but the deliberate necessary inhabitants of one wing of a perfectly structured cosmic cathedral. The silence of the universe is not a sign of its emptiness, but a consequence of its perfect symmetry. But even if we can never meet, never speak, never cross that final frontier of time, the search for evidence is now underway. We are building detectors of unprecedented sensitivity, listening for the faintest gravitational whispers from the moment of creation, searching for a signature that could only come from two universes being born back to back. We are sifting through the torrent of data from our particle colliders, looking for the telltale signs of particles that seem to disappear, as if slipping through a crack into another reality. The cosmic crime scene is no longer cold. We have a new suspect, a new narrative, a story not of cosmic imbalance but of a hidden perfect order. And now we must ask the most thrilling question of all: if this majestic mirrored reality truly exists, a universe locked in a temporal embrace with our own, what clues has it left behind? What signatures etched into the fabric of our own world could finally allow us to prove that we are indeed one half of a grand cosmic whole? What if your reflection was not just a trick of the light? What if in some profound and fundamental way it was just as real as you are? Not a mere copy, but an equal, a perfect opposite bound to you by an unbreakable law of nature. This is not a question of philosophy, but the very bedrock of physics, a principle so powerful and so elegant that for centuries we believed it to be the ultimate truth of our universe. It is the idea of symmetry, and its story begins not in the cosmos, but in the simple intuitive dance of balance. For every push, there is a pull. For every action, an equal and opposite reaction. This foundational insight from Isaac Newton was our first glimpse into the universe's obsession with equilibrium. It suggested a cosmos that was not random or chaotic, but a grand, intricate machine governed by knowable, balanced rules. A celestial clockwork where every gear had a counter-gear, every force a counter-force. This deep-seated harmony was more than just a convenience for calculation. It was aesthetically pleasing a sign that we were on the right track, that the universe could in fact be understood. It whispered of a fundamental fairness woven into the fabric of reality. Then Albert Einstein took this notion of balance and elevated it into a symphony of cosmic proportions. His theories of relativity were built upon an even grander symmetry, the idea that the laws of physics themselves are universal. They do not change whether you're standing still on Earth or hurtling through the void at nearly the speed of light. There is no privileged position, no special seat in the cosmic theatre. The universe in its majestic indifference plays by the same rules for everyone everywhere. This was a revelation that transformed physics. Symmetry was no longer just a feature of the universe. It was its very language. It became the physicist's North Star, a guiding light in the quest to map the unseen architecture of existence. If your theory was not symmetrical, if it was not elegant, it was likely wrong. The universe, we believed, was a masterpiece of perfect balance. From the spin of a galaxy to the orbit of an electron, everything seemed to be part of a flawlessly balanced equation. This belief gave us a sense of comfort, of order. It told us the cosmos was rational, a place of profound and unshakable logic. For every left there was a right, for every positive a negative. This was the sacred text from which all of physical law was written. But in the early 20th century, as we peered deeper into the atom, into the strange and ghostly realm of the quantum, this beautiful ordered picture began to fray at the edges. The neat classical world dissolved into a fever dream of probabilities and paradoxes, a place where particles could be in multiple places at once, and reality itself seemed to flicker like a faulty light. In this bewildering new landscape, our cherished idea of symmetry faced its greatest and most unexpected trial. The challenge arose not from an experiment, but from the mind of one man and the strange prophecy concealed within a single, beautiful equation. His name was Paul Dirac, a figure of profound genius as known for his almost pathological reticence as for his revolutionary contributions to physics. He was a man who saw the universe not as a collection of things, but as a manifestation of pure mathematics. For Dirac, an equation was not merely a tool to describe reality. It was a window into its very soul. And he believed with an almost religious fervour that the soul of the universe had to be symmetrical, had to be beautiful. In 1928, he embarked on a quest to solve one of the greatest problems of his day, to unite the new strange rules of quantum mechanics with Einstein's theory of special relativity. He was trying to write the definitive equation for the electron, the fundamental particle of electricity and matter. After months of intense work, he succeeded. The Dirac equation was a masterpiece of mathematical elegance. Compact, powerful, and perfectly symmetrical, it described the behaviour of the electron with stunning precision. It was a triumph, but it held a dark secret, a ghost in the machine. The equation in its perfect symmetry didn't just have one solution, it had two. One solution described the electron we all know and love, the particle with a negative charge. But the other solution was deeply disturbing. It described an electron with positive energy, but it behaved as if it had a negative mass, an impossible nonsensical idea. Or interpreted another way, it described a particle identical to the electron in every way, sharing its mass, its spin, its very essence, but possessing the exact opposite electrical charge, a positive electron. This was unheard of, unimagined. The known universe was built of protons, neutrons, and electrons. There was no room in this cosmic family for such a bizarre doppelganger. The physics community was baffled. Most, including the titans of the field, urged Dirac to dismiss this second solution as a mere mathematical artifact, a meaningless quirk of the numbers. It was a phantom, they argued, a flaw in an otherwise brilliant theory. To discard it was the only sensible path forward. But Dirac could not. His unwavering faith in mathematical symmetry forbade it. The equation was too beautiful, too perfect to be flawed. If the math predicted this particle, then reality had to provide it. He made a daring, almost mystical leap of logic. He refused to ignore the reflection in the mathematical mirror. In a stunning act of theoretical courage, he declared that this particle must be real. For every particle of matter, he proposed, there must exist an equal and opposite twin, an antiparticle. He predicted the existence of an entire shadow realm of antimatter, an anti-electron, an antiproton, an entire periodic table of anti-elements. This was not science fiction. It was a direct prophecy born from the stubborn insistence that the universe at its most fundamental level must be symmetrical. If you were to meet your antimatter self, you would see a perfect twin, but the moment you shook hands, you would both vanish. Not into nothingness, but into a flash of pure energy, a final violent testament to nature's law of balance. Matter and antimatter were predicted to be the ultimate annihilating pair, the yin and yang of existence locked in a dance of creation and destruction. For years, Dirac's prophecy remained just that, a ghostly prediction. An idea so strange it teetered on the edge of absurdity. An entire universe of mirror particles unseen, unfelt, unheard. It seemed more like a mystical belief than a scientific hypothesis. The world of physics held its breath, waiting for reality to cast its vote. The verdict would not come from the hushed halls of Cambridge, but from the skies above, carried to Earth by cosmic travellers that had journeyed for millions of years across the interstellar dark. The confirmation arrived in 1932 in a small laboratory in California. Physicist Carl Anderson was not hunting for antimatter. He was studying cosmic rays, high-energy particles from deep space that constantly bombard our planet. He was using a device called a cloud chamber, a kind of particle detector that allows you to see the invisible tracks left by subatomic particles as they pass through. It's like seeing the wake of a boat long after the boat itself has gone. To analyze these particles, Anderson placed his chamber in a powerful magnetic field. This field would cause charged particles to curve as they flew through. Negatively charged particles like electrons would curve one way. Positively charged particles like protons would curve the other. Day after day, he photographed the ethereal trails. Most were predictable. The familiar curve of an electron here, the heavier, straighter track of a proton there. It was routine, painstaking work, until one photograph changed everything. There in the ghostly white mist of the chamber was a track. It was thin and delicate, with the exact same curvature as an electron, meaning it had the same mass and the same amount of charge. But it had curved the wrong way. It had curved in the direction of a positive particle. It was not a proton. A proton was 2,000 times heavier. Its track would have been thick and straight, a cosmic bowling ball, compared to this particle's graceful arc. Anderson checked his equipment. He reran the experiment. The track appeared again and again. Unmistakable. It was a particle with the mass of an electron but the charge of a proton. He had discovered the anti-electron. Dirac's ghost was real. He called it the positron. The news electrified the scientific world. The sheer audacity of Dirac's prediction, born from pure mathematics and faith in symmetry, was now confirmed by physical, tangible evidence. It was one of the most stunning moments in the history of science. The universe did possess this profound hidden symmetry. Our reality was not a solo performance, it was a duet. For every particle that makes up our world, there is a mirror image, an antiparticle. Symmetry was not just a guiding principle, it was the divine architect's blueprint. The discovery opened up a breathtaking new vision of the cosmos. We began to imagine anti-stars fueled by anti-hydrogen burning in anti-galaxies. Perhaps somewhere out there in the vastness was an entire half of the universe made of this mirror substance. This perfect balance seemed to answer a fundamental question: how did something come from nothing? In the fiery crucible of the Big Bang, energy could condense into particles, but to conserve the balance, to keep the cosmic ledger at zero, every particle of matter created must have been accompanied by a corresponding particle of antimatter. For every electron a positron, for every quark an antiquark, a perfect one-to-one creation. The infant universe must have been a seething cauldron of both an immaculate equilibrium of matter and its mirror, and in this moment of supreme triumph for the principle of symmetry, as we celebrated this newfound perfect harmony, we stumbled headfirst into the most colossal, the most terrifying mystery in the history of all science, a cosmic crime scene on an unimaginable scale. Because if matter and antimatter are always created in perfect pairs, and if they annihilate each other on contact, then in the first moments after the Big Bang, as the universe expanded and cooled, a cosmic apocalypse should have occurred. Every particle should have found its antiparticle twin. The entire cosmos should have flawlessly symmetrically annihilated itself. Our universe should not exist. There should be nothing here. No galaxies, no stars, no planets, no life. Nothing but a vast, empty, silent void filled with a diffuse, fading sea of light, the leftover energy from that final universal act of self-destruction. And yet here we are. You are here. You are sitting here, a thinking, breathing being, a complex collection of 100 trillion atoms. The earth beneath your feet, the air you breathe, the star that warms your face, it is all made of matter. Everything we can see, everything we have ever touched or measured, from the most distant quasar to the device you're watching this on right now, is matter. There are no anti-galaxies, no anti-stars. We have searched. We have looked for the telltale gamma-ray signatures that would signal the boundary where matter and antimatter meet and annihilate. We have found nothing but an eerie cosmic silence. It appears we live in a universe of leftovers, a universe where one side of the equation, one half of the perfectly balanced pair, has almost completely vanished. Somewhere in the first fleeting microsecond of creation, the perfect symmetry was broken. The scales were tipped. For every billion pairs of matter and antimatter particles that annihilated each other, somehow a single solitary matter particle was left behind. It was a tiny imbalance, a minuscule rounding error in the cosmic math. 1 part in a billion! But that tiny leftover fraction is everything you have ever known. It is the seed of our existence. We are the survivors of a war we cannot comprehend, the progeny of a broken symmetry. This is the great unanswered question. This is the central enigma. Where did all the antimatter go? What force, what unknown law of nature intervened in that first instant to save matter from its own reflection? What tipped the scales in our favour, allowing a universe of substance to emerge from the balanced perfection of the void? The search for the missing antimatter is more than a cosmic detective story. It is a quest to understand why we are here at all. It forces us to confront the possibility that the beautiful, elegant symmetry we cherished for so long is not the final word, that beneath this apparent order lies a deeper, stranger, and more subtle truth, a truth that allowed for a flaw in creation, a flaw that allowed for us. To solve this mystery, we must journey back to the dawn of time itself, to an era of unimaginable energies, where the forces of nature were one, and the laws of physics as we know them had not yet been written. We must hunt for a ghost that disappeared 13.8 billion years ago, leaving behind only one clue: our own unlikely existence. The trail is cold, the evidence is scant, but the stakes could not be higher, for in finding the fate of the universe's lost half, we might just discover the true reason for our own. And so the greatest ghost hunt in the history of science began not in a haunted castle, but in the pristine, unforgiving language of mathematics. The equations themselves, elegant and absolute, had whispered of a phantom, a shadow world lurking just beyond our perception, a universe perfectly inverted, populated by antiparticles. For every electron that sketches the world of our senses, there had to be an anti-electron, a particle identical in every way, except for one fundamental property, its electrical charge. It was a prediction so strange, so contrary to all human experience, that its own author, the brilliant and reserved Paul Dirac, was deeply unsettled by the implications of his own mind. He had peered into the machinery of reality and found a gear turning in reverse. To most physicists of the era, it was a mathematical curiosity, a ghost in the machine that would surely be exorcised by a more complete theory. but a few bold minds wondered. What if the ghost was real? How would you even begin to look for something that upon meeting its counterpart would vanish in a blaze of pure energy? You couldn't hold it. You couldn't store it. You could only hope to catch a fleeting glimpse of its passage. The search required a window into the most violent events in the cosmos, a way to read the shrapnel from distant stellar explosions. The messengers were cosmic rays, high-energy particles raining down from space, smashing into our atmosphere in a constant, silent celestial hailstorm. These collisions were nature's own particle accelerators, momentarily creating conditions of unimaginable energy, a fleeting echo of the universe's birth. In 1932, a young American physicist named Carl Anderson sat watching the ghostly trails left by these cosmic travelers. His instrument was a cloud chamber, a beautiful, almost magical device where particles themselves invisible trace ephemeral contrails of mist like phantom scribes writing the laws of the universe. Anderson placed his chamber in a powerful magnetic field, a tool designed to sort the cosmic debris. Positively charged particles would curve one way, negatively charged particles the other. He was hunting for the known for protons and electrons. But then he saw it. A track. A wisp of condensation arcing through the magnetic field. From the curve's radius and the trail's thickness, he could tell it had the exact same mass as an electron. It was an electron in every way but one. It was curving the wrong way. It was bending with the unmistakable signature of a positive charge. Imagine staring at a photograph of a ghost you never knew you were hunting, only to find it staring back at you, a perfect impossible twin. Anderson had captured the first definitive image of antimatter. He called it the positron. Dirac's phantom was real. The door to the anti-world, once a mere theoretical curiosity, had been blown wide open. The discovery sent a shockwave through the scientific world. If the electron had a twin, what about the other particles that make up our reality? Did the sturdy familiar proton, the very heart of every atom in your body, also have a shadowy counterpart? The challenge here was immensely greater. A proton is nearly 2,000 times more massive than an electron. Creating an antiproton wouldn't be as simple as watching cosmic rays. It would require humanity to build a machine that could replicate on a small scale the fury of a dying star. We had to build a volcano to forge a single anti-atomic heart. The task fell to a monumental piece of engineering in Berkeley, California, the Bevatron. It was a circular titan of steel and magnets, a gravitational slingshot for particles designed to whip protons to nearly the speed of light before smashing them into a stationary target of solid copper. The sheer violence of these collisions provided the energy, the raw material from which new realities could be born, briefly converting the energy of motion into the currency of mass, as dictated by Einstein's famous law EMC2. For years, the machine roared, accelerating, smashing, sifting through the debris. Then in 1955, after analysing tens of thousands of photographs of the subatomic shrapnel, the team led by Emilio Segre and Owen Chamberlain found them. The unmistakable tracks of particles with the proton's mass but a negative charge. The antiproton had been wrenched from the void and into existence. The fundamental pillars of our world, the electron and the proton, both had their mirror image twins. The anti-world wasn't just a quirky exception, it was a governing principle. The next step was as logical as it was profound. If we had an anti-electron, the positron, and an antiproton, could we combine them? Could we build an atom of antimatter? It took another 4 decades of painstaking technological advancement, but in 1995, at the CERN laboratory in Geneva, scientists achieved the seemingly impossible. They carefully guided a slow-moving antiproton and coaxed a positron into its orbit. For a few fleeting, glorious nanoseconds, anti-hydrogen existed on Earth. It was a perfect mirror of a normal hydrogen atom, an antiproton nucleus orbited by an anti-electron. We had not just found the ghost, we had learned its language, understood its anatomy, and built a tiny piece of its world right here in ours. This breathtaking success revealed a universe of profound and unnerving symmetry. It seemed for every cog in the cosmic machine there was an identical anti-cog. For every law, an anti-law. For every us, a potential anti-us. Physicists now needed a single overarching principle to describe this perfect mirror, a kind of ultimate guarantee of cosmic balance. That guarantee was found in one of the most fundamental tenets of modern physics, the CPT theorem. It stands for charge parity in time. Think of it as the universe's ultimate set of instructions for building a mirror image. First there is C for charge conjugation. This is the simplest flip. You take every particle in a system and swap it with its antiparticle. Every positive becomes a negative, every negative a positive. It's like changing the ink in the cosmic pen from black to white. Next, there is P for parity transformation, which is the mirror itself. Imagine an event, any event happening in front of you. Now imagine watching it in a mirror. Everything is spatially inverted. Left becomes right, right becomes left. A clockwise spin becomes a counterclockwise spin. Parity symmetry suggests that the laws of physics shouldn't care whether they are playing out in our world or in a looking-glass version of it. The reflection should be just as valid as the original. Finally, and most mind-bendingly, there is T for time reversal. This is like running the cosmic film backward. If you watch a collision between two billiard balls, the reversed footage of them flying apart looks perfectly plausible. At the most fundamental level, the laws of motion seem to work just as well in reverse as they do forwards. The CPT theorem is the grand symphony of these three symmetries. It states with the force of mathematical proof that if you apply all three transformations at once, if you swap all particles with their antiparticles, view the entire system in a mirror, and run the whole process backward in time, the resulting anti-mirror backward world must obey the exact same physical laws as our own. It's a cosmic guarantee of balance. Any violation in one symmetry must be precisely cancelled out by a violation in the others. CPT invariance became the bedrock of particle physics, a statement of such profound elegance that it felt like the final word on the matter. It suggested a universe that was at its deepest level perfectly fair, perfectly balanced. And for the grand puzzle of our own existence, this was a disaster. A perfectly symmetric universe governed by the perfect CPT theorem should have produced equal amounts of matter and antimatter in the Big Bang. And that equal mixture should have annihilated, leaving behind nothing but a thin cold bath of light. Our existence, the fact that you are here to ponder this question, is the most powerful evidence that the universe is not perfectly symmetric. The beautiful pristine mirror had to have a flaw. Somewhere in the cosmic looking glass there had to be a crack. And so the hunt began anew. Not for new particles this time, but for a flaw in the laws themselves. The search focused on parity. Was the universe truly ambidextrous, or did it for some bizarre reason have a preferred handedness? In a landmark experiment in 1956, the physicist Chen-Shung Wu observed the radioactive decay of cobalt-60 atoms. What she found was shocking. The electrons produced in the decay were not emitted randomly in all directions. They showed a distinct preference for one direction of spin over the other. It was as if the universe at the subatomic level knew its left from its right. Parity symmetry was shattered. The mirror, it turned out, was warped. This was a monumental discovery, but it didn't solve the bigger problem. Physicists quickly realized that while parity P was violated, if you combined it with charge conjugation C, the symmetry was restored. The combined operation CP seemed to hold. An anticobalt atom decaying in a mirror would look exactly like our own. The balance, it seemed, was restored just at a deeper level. The universe wasn't left-right symmetric, but it was symmetric if you swapped left for right. And matter for antimatter. CP symmetry became the new paradigm. It was a slightly more complex, slightly less intuitive form of balance, but it was balance nonetheless. For a few years it seemed we had found the new bedrock, and then in 1964 the universe threw another curveball, and it came from a strange ephemeral particle called a neutral kaon. Kaons are unstable living for just fractions of a second before decaying. According to the law of CP symmetry, the particle and its antiparticle should have decayed in ways that were perfect mirror images of each other, but they didn't. Physicists James Cronin and Val Fitch, in a painstakingly precise experiment, found that in a vast sea of kaon decays, a tiny, almost imperceptible number, about 2 in every 1,000, violated the rule. They decayed in a way that was forbidden by CP symmetry. It was a whisper of a violation, a single note played out of tune in the cosmic symphony, but it was undeniably there. The mirror wasn't just warped, it was cracked. This was the clue we'd been looking for, a confirmed measurable difference in the laws of physics for matter and antimatter, a tiny built-in bias in the fabric of reality itself. CP violation was the first crack of light in the darkroom of our cosmic origins. It provided a possible mechanism, a way for a universe born with equal parts to end up with a slight surplus of one over the other. Perhaps in the inferno of the Big Bang, the decays of some primordial particles favoured matter ever so slightly. Over countless interactions in that first second, that tiny preference could accumulate, leaving behind one matter particle for every billion that were annihilated. That 1 in a billion survivor is everything we see. It's every galaxy, every star, every planet, and every one of us. We are the leftovers, the statistical anomaly in a cosmic war of annihilation, made possible by a flaw in the mirror. But the story doesn't end there. The CPT theorem, that grand guarantee of total balance, still held firm. And it made a startling prediction. If CP symmetry is violated and the overall CPT balance must be maintained, then the final symmetry time reversal must also be violated. The two flaws must perfectly cancel each other out to preserve the whole. This is perhaps the most profound and unsettling idea of all. It suggests that the laws of physics themselves have a preferred direction in time. Running the film of certain particle interactions backward does not give you a physically plausible result. The universe, at its most granular level, has an arrow of time woven into its laws. It took decades of further experimentation at massive facilities like CERN and SLEC to finally confirm this. They studied the oscillations of other exotic particles called B mesons and found the telltale signature. T violation was real. The forward march of time wasn't just a matter of entropy and increasing disorder as we experience it in our large-scale world. It was a fundamental bias written into the source code of reality. The past and the future are not at the quantum level interchangeable. We had done it. We had followed the ghostly prediction from Dirac's mind to the creation of whole antiatoms in our labs. We had formulated a beautiful law of perfect symmetry CPT, only to discover, through painstaking experiment, that two of its three components, CP and T, were individually flawed. We had found the crack in the cosmic mirror. We had found the universe's subtle inbuilt preference for matter over antimatter, and for the future over the past. It should have been the final triumphant answer to the question of our existence, but it wasn't. When scientists did the math when they took the measured size of CP violation, that tiny 2 in 1,000 flaw, and plugged it into the models of the early universe, the numbers didn't add up. Not even close. The asymmetry we've observed in our laboratories is real. It is profound. But it is orders of magnitude too small, too weak, too insignificant to explain the colossal imbalance we see in the heavens. It can account for a pebble of matter surviving when we need to explain an entire mountain range. The discovery of CP violation wasn't the solution. It was a breadcrumb. A vital clue, yes, but one that points toward a much larger, much deeper mystery. The small crack we found in the mirror doesn't explain why the entire mirror world seems to be missing. Our local laws are slightly biased, but not nearly biased enough. Something else must have been at play in that first critical moment. A more powerful force, a more fundamental asymmetry, a more radical departure from the perfect symmetry we once imagined. The search had led us to the edge of our understanding, staring into an explanatory abyss. And to cross it, we would have to entertain ideas that make the concept of an anti-world seem tame by comparison. And so we find ourselves at a profound, almost philosophical impasse. We stand before the grandest cosmic mystery armed with our most elegant equations, only to find they point to a contradiction etched into the very fabric of existence. The universe in its glorious, sprawling reality seems to be a flagrant violation of its own deepest law. CPT-Symmetry, that sacred pact which declares that the laws of physics must remain unchanged if we flip charge invert space and reverse time, appears to be broken on a scale so vast it is almost unimaginable. Our cosmos is a testament to this imbalance, a lonely monument of matter in a void that should be teeming with its antimatter counterpart. The symmetry is shattered. The equation does not balance. The universe we inhabit, the only one we have ever known, simply should not be here. It is a mathematical impossibility that we can touch, see, and feel. For generations, this paradox has haunted the quiet corridors of theoretical physics, a ghost in the machine of cosmology. It suggests that either our understanding of fundamental symmetry is flawed, or there is a piece of the puzzle so enormous, so utterly game-changing, that we have failed to even conceive of it. What if the error lies not in our equations, but in our perspective? What if the universe we are measuring is not the complete system? We have been staring at a single page, trying to comprehend the entire epic. We've been listening to one voice in a choir, wondering why the harmony feels incomplete. The boldest minds in physics, pushed to the very brink of reason, began to ask a question as daring as it was simple. What if the crime scene isn't the whole story? What if the broken symmetry we observe is an illusion, a local distortion caused by our limited view? They proposed an answer of breathtaking audacity, a solution that doesn't just tweak the existing model, but shatters its very frame. Perhaps the CPT symmetry of the cosmos is perfectly preserved. Perhaps the universal ledger does balance to a perfect zero. We are just looking at one side of the accounts. The idea suggests that our universe is not alone. It posits that for the grand cosmic equation to be whole, our reality must be just one half of a perfectly symmetrical pair. It suggests that at the moment of creation, the Big Bang did not give birth to one universe but to two, a universe and an anti-universe, a cosmos and its perfect untouchable mirror. This is not science fiction, but a serious though speculative consequence of taking our most cherished physical principles to their ultimate conclusion. It is a concept that reframes our entire existence, suggesting we are but a single partial reflection in a much grander, perfectly balanced reality. Imagine for a moment standing on the shore of a perfectly still infinite lake. You see the world around you, the stars, the galaxies, your own reflection. Now imagine that the reflection is not just an image, but a place, a physical reality as real as your own. This is the essence of the mirror universe hypothesis. It is our cosmos's CPT reflection made manifest. Let's break down what that truly means. The C in CPT stands for charge conjugation. In this mirror realm, every particle that constitutes our world has its charge inverted. Every proton, the stable heart of our atomic nuclei, would be an antiproton seething with negative charge. Every electron, the architect of our chemical bonds, would be a positron, its antimatter nemesis. An entire anti-chemistry would arise from these inverted rules, giving birth to anti-stars, anti-galaxies, and perhaps even anti-life. The very forces that bind our world together would be sculpted from the antimatter we have searched for in vain. The reason we see an overwhelming dominance of matter here is because the corresponding antimatter isn't missing. It's simply sequestered away, forming the bedrock of its own parallel existence. The cosmic books are balanced, but on a ledger that spans two distinct realities. Every atom here is cancelled out by an anti-atom there. The total charge of the entire system, the combined duoverse, is a perfect, elegant zero. The P stands for parity, the spatial mirror. In this anti-universe, left is right and right is left. This isn't just a simple reversal of direction, but a fundamental inversion of the universe's intrinsic handedness. Many processes in particle physics have a preferred orientation, a subtle bias in the way particles decay or interact. The weak nuclear force which governs radioactive decay famously violates parity symmetry. It can tell the difference between left and right. In our universe, certain particles will always spin in one direction, relative to their motion, like a celestial screw with a left-handed thread. But in the mirror world, this cosmic screw is right-handed. Every fundamental interaction that has a spatial preference in our cosmos has the opposite preference there. This creates a perfect spatial reflection. If you could somehow reach across and shake hands with your mirror self, your right hand would meet their left. It is a world geometrically inverted, a photographic negative of our own spatial reality. The subtle asymmetries that pepper our universe are perfectly counteracted by their inverse asymmetries next door, restoring a flawless overarching parity to the cosmic whole. Every spin, every decay, every quantum wobble that leans one way here leans the other way there. And then we come to T, the most profound and mind-altering transformation of all time reversal. For the CPT-Symmetry to be completely upheld across this cosmic dyad, the anti-universe must not only be charge-flipped and space-inverted, but its temporal arrow must be reversed relative to our own. It must be a universe that from our perspective is flowing backwards in time. This concept is staggering. It suggests that the Big Bang was not just a singular explosion into time, but a central symmetrical event within time. Imagine the moment of creation not as a starting pistol, but as the explosive centre of an hourglass. From that singular, infinitely dense point of origin, two cones of space-time erupted. One expanded forward in time, becoming our universe, with entropy increasing, stars burning out, and complexity growing away from that initial primordial state. The other cone expanded in the opposite direction, a universe journeying backwards from our point of view. For any inhabitants of that mirror world, their experience of time would be perfectly normal. Their clocks would tick forward. Their entropy would increase away from their Big Bang. They would remember their past and anticipate their future just as we do. Their past would simply be what we call our future, and vice versa. Two great cosmic rivers originating from the same singular spring, but flowing in opposite directions towards eternity. This vision of a Janus-faced creation looking in two temporal directions at once solves one of the deepest conundrums in physics, the something-from-nothing problem. How could an entire universe with all its matter and energy spontaneously erupt from a void? In this model, it didn't. The total energy of our universe is a massive positive number. But if the anti-universe has a time flow opposite to ours, its total energy from a global perspective is a massive negative number. When you add the two together, our universe and its time-reverse twin, the sum is zero. The net charge is zero. The net spin is zero. The net momentum is zero. The entire system, the true universe with a capital U, is a perfect state of nothingness, beautifully and symmetrically cleaved into two opposing halves that we perceive as something. It is the ultimate cosmic loophole. Creation without breaking the laws of conservation. The universe and its anti-universe are like a particle and antiparticle pair, created spontaneously from the quantum foam of a pre-cosmic state, only on an infinitely grander scale. They are two sides of a single cosmic coin minted at the dawn of time, each giving the other meaning and existence through their perfect opposition. Suddenly the glaring asymmetry of our world is cast in a new light. It is no longer a flaw in the fabric of physics, but a necessary condition of our half of the equation. We live in the matter-dominated universe, because that is what it is, the matter, half of a matter-antimatter pair. The lack of antimatter is no longer a mystery to be solved, but a defining characteristic of our cosmic address. The search for the missing antimatter was always destined to fail, for it was like searching for the reflection of a mountain within the mountain itself. The reflection is real, but it exists in the lake, not on the land. This reframing is profound. It suggests that the laws of nature are even more perfect, more sublimely symmetrical than we ever dared to imagine. The brokenness we perceived was a trick of the light, a parochial viewpoint from deep within one of the two great cosmic halls. From a hypothetical vantage point outside of space-time, the full architecture would be revealed a perfectly balanced, stunningly elegant diptych where every particle, every force, every moment in our universe has its precise balancing counterpart in another. But what would this world be like? It would not be a simple cartoonish opposite of ours. It would be governed by the exact same laws of physics. Gravity would pull stars, would fuse anti-hydrogen into anti-helium, and the great cosmic web of anti-galaxies would evolve over billions of years. To its inhabitants, their reality would be entirely self-contained and logical. They would look out at their night sky, see the light from distant anti-stars, and ponder the same questions we do. They too would measure their cosmic microwave background, a relic of their own Big Bang. They too would likely discover a universe seemingly made of only one type of matter, their antimatter, and they too would be mystified by the asymmetry. They would be our cosmic twins, separated at birth, living out parallel lives governed by the same rulebook, but with all the key characters inverted. They would be forever unaware of us just as we are of them, each of us convinced that our lonely reality is the only one. The separation between these two universes would be absolute, more profound than any ocean or any interstellar void. They do not exist side by side in some higher dimensional space. They are separated by the most fundamental barrier of all, the direction of time's arrow itself. To cross from one to the other would require reversing one's own temporal flow, an act that is physically impossible. They are two stories in the same book, but one is read from front to back and the other from back to front. Their narratives can never meet. They are forever connected at their mutual origin, the Big Bang, but they are destined to expand infinitely far from one another in the dimension of time. This inherent isolation is both frustrating and beautiful. It preserves the integrity of each universe while upholding the perfect symmetry of the whole. It is a cosmic architecture of stunning grandeur, a reality built on a foundation of duality. For every beginning we experience there is an ending in their world. For every star that is born here, its anti-star twin is perhaps dying there in the reversed temporal flow. And yet, could there be a whisper, a faint ghostly echo, across the temporal chasm, while the forces that govern particles, the strong, weak and electromagnetic forces, are all CPT-Symmetric, and would thus be perfectly confined to their respective universes, there is one force that might be an exception. One fundamental interaction that is blind to the distinctions of charge, indifferent to the direction of spin, and possibly even ambivalent to the flow of time itself. That force, of course, is gravity. Gravity is the pure geometry of space-time. It is the curvature created by mass and energy regardless of what form that mass energy takes. An anti-star made of antimatter would generate the exact same gravitational field as its regular matter counterpart. This opens up a tantalizing, almost ghostly possibility. Could the gravitational influence of this mirror universe leak across the divide? Could its immense unseen mass be pulling on our own, shaping the evolution of our galaxies in ways we cannot explain? We see the effects of some invisible substance all around us. We call it dark matter. We have searched for it for decades, but every particle we have theorized has eluded detection. We are surrounded by a gravitational ghost that accounts for more than 80% of the matter in the universe, and we have absolutely no idea what it is. Perhaps we have been searching in the wrong place. Perhaps dark matter is not a new exotic particle hiding within our own universe at all. What if it is the answer to a question we never thought to ask? What if the phantom gravitational pull we detect across the cosmos is nothing less than the faint gravitational handshake of our own mirror twin? The possibility is staggering. It suggests that the anti-stars, anti-galaxies and anti-clusters of the other universe are gravitationally coupled to our own. We cannot see them, we cannot touch them, but we can feel them. We can feel their immense weight pulling on the edges of our Milky Way, holding our galactic clusters together, sculpting the largest structures in the cosmos. In this view, every galaxy we see is potentially nestled within a much larger invisible halo, made not of mysterious particles, but of ordinary antimatter gravitationally bound to us from a reality running backwards in time. The cosmic dance of galaxies would be a dance of two partners, one visible and one invisible, forever entwined by the long reach of gravity. This is the first testable prediction of this incredible idea, the first glimmer of a way to peer into the looking glass and see if a reflection is truly staring back. Undefined. And so we are left standing on a cognitive precipice, staring into an abyss of possibility so profound it threatens to redefine our place in the cosmos. The mathematics, in its cold, crystalline logic, presents us with this ghost in the machine of reality, a second universe, a perfect reflection, born from the very same fire as our own, yet forever hidden behind a one-way mirror. It is not a parallel world in some distant dimension, but an anti-universe superimposed upon our own reality, sharing our space-time yet utterly impenetrably separate. Its heart beats in reverse, its future is our past, a winding river of time flowing back towards the singularity we both call origin. The sheer elegance of this CPT-Symmetric solution resolving one of physics' most stubborn paradoxes is intoxicating. But it forces upon us a question that is at once terrifying and exhilarating. If our cosmic twin is truly there, occupying the same space we do, breathing the same vacuum, how could we possibly know? How do you see the invisible? How do you touch the intangible? The barrier between our worlds would be almost absolute, a fortress built from the fundamental laws of nature themselves. Imagine its particles, the mirror protons and mirror electrons swirling into mirror atoms. They would be governed by their own set of forces. A mirror photon, the particle of its light, would be a phantom to our eyes. You could be bathed in the light of 1 billion mirror suns at this very moment, and you would feel nothing, see nothing. Their light would pass through you as if you were glass, as if you were less than a ghost. Their strong nuclear force would bind their mirror quarks into mirror nuclei, a process completely alien to our own atomic matter. Their electromagnetism would weave its own intricate tapestry of fields and currents, a vibrant, complex reality to which we are completely blind and numb. It's a staggering thought, an entire cosmos perhaps teeming with its own mirror galaxies, mirror stars, and even mirror life could be unfolding its history in the very room you're in now, its existence a silent opera played on instruments we can never hear. Yet this perfect separation, this cosmic segregation might be the very key to solving one of the greatest mysteries in the history of science. For decades we have been haunted by a phantom we can detect but cannot see. We have watched galaxies spinning so fast they should tear themselves apart, their outer stars moving at impossible velocities. We have observed clusters of galaxies held together by an immense unseen gravitational glue. Something is out there, something with mass, something that pervades the universe, accounting for more than 80% of all matter. We call it dark matter, a name that is less of a description and more of an admission of our profound ignorance. We have built detectors of unimaginable sensitivity, placing them deep underground to shield them from cosmic noise, waiting for a whisper from this dark realm. And for decades they have heard only silence. But what if we have been searching for the wrong thing entirely? What if dark matter isn't some new exotic undiscovered particle from our own universe's menagerie? What if it is something far grander, far more elegant? What if dark matter is simply everything in the other universe? The CPT-Symmetric model proposes a solution of breathtaking simplicity. The mirror particles, the mirror hydrogen, the mirror helium, all of it would not interact with our light or our forces. They would be by their very nature dark. But they would still possess mass. And mass, as Einstein taught us, warps the fabric of space-time. This is the one language both universes must speak, the one fundamental interaction that transcends the mirror, gravity. The unseen gravitational influence we attribute to dark matter could be nothing less than the collective gravitational pull of the entire mirror universe. Suddenly, the phantom in the cosmos gains a face. The invisible halos we map around galaxies are no longer just abstract blobs of mysterious matter. They could be the gravitational footprints of entire mirror galaxies, co-rotating with our own locked in an eternal invisible dance. Imagine our Milky Way. For every one of our stars you see shining in the night sky, there could be a mirror star composed of mirror matter, occupying a similar position in its own ghostly spiral gravitationally tethered to ours. Two complete galaxies, one of matter, one of its CPT reflection, nested together like cosmic Russian dolls. They are separate ecosystems, each with its own light, its own chemistry, its own potential for life, yet bound together by the shared curvature of space-time they both inhabit. This invisible twin would be the cosmic anchor holding our own galaxy together, the unseen shepherd guiding the flock of our stars. It is no longer a missing piece of our universe, but a complete parallel cosmos, whose shadow we have been mistaking for a monster. This isn't just a theory. It provides testable predictions. If this is true, the dark matter halos shouldn't be perfectly smooth. They should have structure. They should clump and form substructures just as our own matter does. They should contain the ghosts of mirror star clusters and dwarf mirror galaxies, and their subtle gravitational lumps and bumps are something our astronomers are now hunting for, with ever more powerful telescopes, searching for tiny distortions in the light from distant galaxies, the telltale sign of a hidden lumpy structure within the darkness. If gravity is indeed the universal bridge, the cosmic Rosetta Stone allowing us to translate the existence of one universe into the language of the other, then it offers us our most dramatic and direct way of listening for a signal. Not with light, but with the very ringing of space-time itself. For the past decade, humanity has developed a new sense, an ability to feel the vibrations of the cosmos. Gravitational wave observatories like LIGO and Virgo are not telescopes, they are celestial seismographs. They can detect the most violent events in the universe, the collision of black holes, the merging of neutron stars by feeling the infinitesimal ripple that these cataclysms send shuddering through the fabric of reality. Now consider a cataclysm in the mirror universe. Imagine two mirror black holes, titans of their realm, locked in a death spiral for millions of years. As they merge, they would unleash a storm of gravitational waves, a tempest in space-time. Because gravity is universal, that storm would not be confined to their universe. It would propagate into ours a tsunami of pure geometry, utterly indifferent to the nature of the matter it passes through. Our detectors on Earth would register the event. The lasers in their long evacuated arms would shiver, recording the characteristic chirp of a binary black hole merger. We would analyze the signal, calculate the masses, the distance, the spin. It would look for all intents and purposes like an event from our own cosmos. But there would be one crucial, deafeningly silent clue. When black holes in our universe merge, the event is often accompanied by a spectacular firework display across the electromagnetic spectrum, especially if they are surrounded by matter. Our telescopes, alerted by the gravitational wave signal, would frantically scan that patch of sky looking for a flash of light, a burst of gamma rays, a radio afterglow. In this case, they would find nothing. Absolute, impenetrable darkness. It would be a silent scream from across the reality divide, a gravitational wave event completely naked of any light. Such a dark merger would be the most powerful circumstantial evidence imaginable for a hidden interacting cosmos. We would have heard the thunder from a storm on an invisible world. We have in fact already detected black hole mergers that have had no optical counterpart, and while these are perfectly consistent with isolated events in our own universe, each one adds a tantalizing piece to a puzzle that could have a far more extraordinary solution. The search, however, cannot rely solely on waiting for these singular violent announcements. The clues may be far more subtle, woven into the very fabric of our ongoing cosmic observations like faint watermarks on the pages of reality. Physicists, like cosmic detectives, are now re-examining strange anomalous signals that have puzzled them for years, looking at them through this new CPT-Symmetric lens. One of the most promising lines of inquiry involves the most elusive of particles, the neutrino. These ghost particles in our own universe barely interact with matter. Trillions pass through your body every second without a trace. Their mirror counterparts would be even more spectral. But what if the mirror between universes is not perfect? What if there are tiny cracks, microscopic portal interactions that allow for a minuscule leakage between worlds? Some theories speculate that a particular kind of particle, the so-called sterile neutrino, might be the key. It doesn't interact with any of our standard forces, but it could be a shared particle, a true ambidextrous entity capable of interacting with both our world and the mirror world. If this were true, it would open up a breathtaking channel of communication. A cataclysmic event in the mirror universe like a mirror supernova would unleash a flood of its mirror neutrinos. A tiny fraction of these through this sterile neutrino portal could transform into our kind of neutrinos, appearing as if from nowhere, carrying energies and travelling in directions that defy conventional astrophysical explanation. Consider the Ice Cube Neutrino Observatory, a truly fantastic instrument buried deep within the Antarctic ice. It uses a cubic kilometre of pristine ice as a detector, watching for the faint blue flashes of light produced when a high-energy neutrino strikes an ice molecule. IceCube's primary purpose is to look for neutrinos arriving from space from above, but it can also detect neutrinos coming from below, those that have travelled through the entire planet. The Earth acts as a massive filter, blocking almost every other particle, but allowing these ghostly neutrinos to pass. A few years ago, the ANITA experiment, a balloon-borne antenna flying over Antarctica, detected something that should be impossible. Two events that looked like ultra-high energy neutrinos bursting up from the ice, as if they had travelled through the planet. This is deeply puzzling. At these extreme energies, the Earth should be completely opaque, even to neutrinos. They should never have made it through. But they did. While mundane explanations are still being exhaustively explored, this profound anomaly has ignited speculation. Could this be a signal from the other side, a mirror particle decaying, a message in a bottle from the anti-universe picked up by our most sensitive detectors at the bottom of the world? This search for subtle fingerprints extends to the most energetic particles known to exist, ultra-high energy cosmic rays. These are single subatomic particles, usually protons, that strike our upper atmosphere with the kinetic energy of a well-thrown baseball. Their origin is one of the biggest mysteries in astrophysics. We cannot identify any object in our own galaxy, or even nearby galaxies, powerful enough to accelerate particles to such ludicrous speeds. The CPT-Symmetric model offers a tantalizing if speculative alternative. What if the barrier between worlds is occasionally breached? Could a mirror meteoroid, a small rock made of mirror matter, drift into our solar system? To our telescopes it would be invisible, but upon entering our atmosphere its mirror atoms would meet our air molecules. The result would not be a simple collision, it would be annihilation. A tiny speck of dust could release the energy of a powerful bomb, creating a cascade of particles that would look to our detectors exactly like an ultra-high energy cosmic ray event, but originating from an empty patch of sky. We would see the explosion but not the bullet. Each one of these orphan cosmic rays, these "oh my god" particles as they are sometimes called, could be a scar, a fleeting wound in the fabric of our reality caused by a visitor from the other side. Perhaps the most profound clue of all, however, lies not in the present, but in the very beginning. We have a photograph of our infant universe, a snapshot taken just 380,000 years after the Big Bang. It is the cosmic microwave background radiation, or CMB, the afterglow of creation. This faint pervasive microwave hiss that fills all of space is not perfectly uniform. It is mottled with tiny temperature fluctuations, hot and cold spots, that represent the seeds of all future structure, the primordial lumps that would eventually grow into the galaxies and clusters we see today. The standard model of cosmology, our reigning theory of the universe's origin and evolution, predicts the statistical pattern of these spots with breathtaking accuracy. It is one of the greatest triumphs of modern science. And yet there are nagging anomalies. Peculiar alignments, unexpected cold spots, and a subtle tension in the universe's expansion rate that hint at something missing from our models. If the mirror universe was born in the same Big Bang, it would have been right there with our own universe in that hot, dense primordial soup. Although its particles could not interact with ours directly, its gravity would have been felt. As our universe's plasma swirled and eddied under the influence of its own gravity, it would have also felt the gentle, persistent gravitational tug of the mirror plasma swirling alongside it. This gravitational coupling would have left a subtle imprint on our cosmic microwave background. It would be like two artists painting on the same canvas in the dark, unable to see each other's work but occasionally bumping elbows, causing a slight unexpected smudge in the final masterpiece. Cosmologists are now meticulously scanning the CMB data, hunting for these specific anomalous patterns, particular modes of oscillation, or correlations in the temperature map that our standard model cannot explain, but which the presence of a mirror sector's gravity would naturally produce. Seeing this faint shadow of a twin in the baby picture of our universe would be revolutionary. It would be archaeological evidence of an unseen civilization not from the distant past, but from a different reality entirely. We stand therefore at a remarkable juncture in our quest for understanding. The path forward is shrouded in fog. The evidence we seek is ephemeral, circumstantial, and buried in the noise of a vast and complex cosmos. It is a search conducted not with bright floodlights, but with the scientific equivalent of listening for a floorboard creaking in an adjacent locked room. Each clue, a silent gravitational wave, an impossible neutrino, an orphan cosmic ray, a strange shadow on the afterglow of creation, is on its own inconclusive. But taken together they begin to paint a coherent, albeit ghostly portrait. They suggest we may not be alone in our own space-time. They hint that the universe we know, the one of stars and light and life, may be only half the story, the illuminated protagonist in a cosmic drama, whose other lead actor has until now remained hidden in the shadows. The search for our universe's mirror is no longer just a fanciful theory. It has become a tangible experimental quest, pushing the boundaries of technology and imagination, forcing us to ask whether the reality we perceive is in fact the only reality there is, and so the theory presents a staggering elegant solution. A cosmic twin, an anti-universe born from the very same genesis event as our own, not as a separate entity in some distant dimension, but as the other side of the primordial coin. It proposes that for every particle of matter that cascaded forward in time to form our stars and galaxies, a corresponding antiparticle surged backward into its own cosmic history. The grand, glaring asymmetry that has haunted physics for a century, the mystery of the missing antimatter is resolved not by its absence, but by its perfect symmetrical sequestration. It was never truly gone. It was simply travelling in the other direction. This CPT-Symmetric model is a masterpiece of theoretical architecture, a cathedral of logic built to house one of the universe's most profound secrets. But cathedrals, no matter how beautiful, can be empty. Without a single concrete piece of observational evidence, this entire construct remains a phantom, a ghost haunting the equations of cosmology. How could we possibly reach across the singular boundary of the Big Bang to find a whisper of this other reality? Where would we even look for a footprint left by a particle that is from our perspective, an echo from the future travelling into the past? You cannot build a telescope to see before the beginning of time. You cannot send a probe to a place where the laws of our causality are inverted. To find proof, we needed a new kind of messenger, one that could traverse the cosmos under an almost perfect cloak of invisibility, a particle so ethereal it could pass through entire planets as if they were mist. We needed a ghost. We needed the neutrino. These particles are the universe's ultimate loners. Produced in the hearts of stars and in the most violent cosmic cataclysms, they stream across the void in unimaginable numbers, billions passing through your body every single second, yet they interact with virtually nothing. They are the closest thing to an unstoppable force in nature. It is this very reluctance to engage with matter that makes them the perfect couriers. While light is blocked by dust and charged particles are bent by magnetic fields, a high-energy neutrino can travel from a distant quasar to Earth in a perfectly straight line carrying a pristine message from its origin. And crucially, theorists realized if a particle were to cross over from this proposed anti-universe, it would most likely manifest in our reality as a specific type of high-energy neutrino. The hunt was on not in the polished cleanrooms of particle accelerators, but in the most desolate primordial landscape left on our planet. We had to go to the end of the world to look for the beginning of everything. Welcome to Antarctica. A continent of ice, a desert of cold where the silence is so profound it feels like a physical presence. The air is the driest and clearest on Earth, and the ice sheet below stretches for miles, a solid crystalline record of our planet's climate, stretching back nearly 1 million years. It is a place fundamentally hostile to life, but for a very specific type of astronomy it is paradise. Here this colossal shield of frozen water, pure and dense, is not an obstacle, it is the detector. Floating high above this otherworldly landscape suspended from a stratospheric balloon, the size of a football stadium is an experiment with a name as unassuming as its quarry, the Antarctic Impulsive Transient Antenna, or ANITA. From its vantage point 23 miles up, its sensitive radio antenna are not pointed up at the stars but down at the ice. ANITA is listening. It is waiting for a subatomic gunshot in the dark. The physics behind its mission is as ingenious as it is subtle. When an ultra-high-energy neutrino from space finally against all odds collides with an atom inside the ice, it unleashes a shower of secondary particles that momentarily travel faster than the speed of light in the ice. This is not a violation of Einstein's cosmic speed limit, but a phenomenon analogous to a sonic boom. Just as a supersonic jet creates a shockwave of sound, this particle shower creates a cone of radio waves, a brief sharp pulse of energy known as a Scarian radiation. ANITA's entire purpose is to listen for the faint crackle of these radio pulses as they emerge from the ice below. For years it floated in the silent stratosphere, detecting the downward cascading signatures of cosmic rays from above, and occasionally the telltale pings of neutrinos entering the ice from space, all behaving exactly as the standard model of particle physics predicted. The experiment was a success, confirming our understanding of these ghostly particles. It was doing its job perfectly, until it detected the impossible. In the meticulously analysed data from its flights too, and then in a later analysis, a third event stood out with terrifying clarity. The signals were clean, powerful, and possessed all the hallmarks of a particle shower. There was just one universe-shattering problem: they were going the wrong way. The radio pulses were not generated by a particle coming down from the sky and plunging into the ice. Instead, they erupted out of the ice as if a particle had shot up from deep within the Earth's core and burst forth into the atmosphere. The events were so extreme in their energy and their trajectory that they seemed to defy the known laws of physics. The team checked and rechecked their instruments, their calculations, their understanding of the Antarctic ice itself. There was no mistake in the data. The signal was real. An ultra-high-energy particle had travelled upwards through thousands of kilometres of our planet's dense rock and mantle to emerge from the South Pole. To grasp the sheer absurdity of this, you must understand what the Earth represents to a high-energy neutrino. For these particles, our planet is not a translucent marble. It is a fortress wall miles thick. Their probability of interacting with matter, while tiny, increases dramatically with their energy. An ultra-high-energy neutrino, like the one Anita's signal implied, has a near-zero chance of making it through the entire planet unscathed. It is, to put it simply, forbidden. Trying to explain these upward-moving events with our existing physics is like finding a bullet hole in a ceiling with the spent casing on the floor below, and concluding that the bullet must have fired itself out of the floor, travelled up through the room, and embedded itself in the ceiling in defiance of gravity. It is a result that doesn't just ask for a new theory, it screams for one. The scientific community rightly scrambled for conventional explanations. Could the signal have been a reflection? Perhaps a downward-moving particle's radio pulse bounced off a subsurface layer of rock in a strange way, mimicking an upward trajectory. Extensive modelling of the ice and the bedrock below showed this to be extraordinarily unlikely. The signal was too clean, too direct. Could it have been an undiscovered feature of the ice itself, some strange lensing effect that distorted the signal's path? Decades of glaciological research made this a remote possibility. Every mundane explanation that was proposed was painstakingly investigated and one by one found wanting. The anomaly remained. It was a single stubborn fact that refused to fit into our tidy picture of the universe. It was a message from somewhere else, a piece of a puzzle we didn't even know we were solving. And that is when a few daring physicists looked back at the CPT-Symmetric model of the universe and felt a shiver of recognition. What if the particle Anita saw was not from our cosmos at all? What if it was a traveller from our twin? Imagine for a moment this mirror universe expanding backward in our time, filled with antimatter. From its own perspective, its arrow of time is perfectly normal. Particles are born, they interact, they decay, all moving from its past toward its future. Now picture a very high-energy particle in that universe. Let's say a tau antineutrino, the antimatter version of one of our own particles. It is travelling through its own cosmos on a collision course with the shared origin point, the Big Bang. From our vantage point, this particle is moving backward in time toward us. As it crosses the temporal boundary of the Big Bang, the fundamental laws of CPT-Symmetry demand that its properties must appear to flip. Its charge reverses, its parity inverts, and its direction in time reverses. The tau antineutrino and antimatter particle travelling forward in its time would burst into our universe appearing as a tau neutrino, a matter particle, now travelling forward in our time. Here is where the theory delivers its masterstroke. This newly appeared particle would emerge from the singularity of the Big Bang, which from our linear perspective happened everywhere at once. It would not be arriving from the distant cosmos, but would instead materialise right here within our local space-time. It would appear as if from nowhere already set on a trajectory. And because of the peculiar geometry of this temporal crossing, the model predicts that some of these particles could appear inside the Earth already moving outwards. They wouldn't have needed to travel through the planet's dense core because their journey didn't begin in deep space. Their journey began at the beginning of time itself, a beginning that is also paradoxically our shared cosmic horizon. The upward-pointing particle shower Anita detected would no longer be an impossibility. It would be a postcard from the anti-world. It would be the first tangible evidence that our universe is not alone, that we are but one half of a far grander, perfectly balanced and breathtakingly strange whole. This idea that the Big Bang was not a singular creation from nothing but a point of reflection in a vast, eternal timeline reframes everything we thought we knew. It gives the cosmos a history before its beginning, and a destiny that is forever entwined with its mirror image. This model, developed by physicists at the Perimeter Institute and elsewhere, proposes that our universe and its anti-universe partner were created together, springing into existence as a particle-antiparticle pair, a universe-anti-universe pair from a pre-existing state. The Big Bang in this view ceases to be an unexplainable, infinitely hot and dense point that defies our physics. Instead, it becomes a much more natural event, a cosmic bounce, where the geometry of space-time itself inverted. Think of it not as the first page of a book, but as the centerfold with a story that reads forwards in one direction and backwards in the other. This isn't just a philosophical sleight of hand to make the math look prettier. It has profound testable consequences. It suggests that the overwhelming uniformity of the early universe, something that inflationary theory has long sought to explain, arises naturally from this symmetrical creation. It also offers a candidate for the enigmatic dark matter that constitutes the vast majority of our universe's mass. In some variations of the CPT model, the partner to our familiar neutrino would be a massive sterile right-handed neutrino, an ideal candidate for the elusive substance that holds our galaxies together. The model doesn't just solve one problem, it potentially solves several of the biggest cosmological puzzles at once. It proposes that the missing antimatter is in the other universe. It proposes that dark matter might be the footprint of its particles in our own, and it gives us a reason for the seemingly arbitrary arrow of time we all experience grounding it in the overall thermodynamic evolution of this greater two-part cosmos. The implications are almost too vast to hold in the mind. If this model is correct, then every particle in your body, every photon of starlight that reaches your eye, every atom in the earth beneath your feet, has a corresponding antiparticle twin, living out its existence in a universe that is a perfect mirror of our own. A universe where from our perspective entropy is decreasing. Stars are gathering gas rather than expelling it, and the flow of events is unwinding back towards the moment of our shared creation. It suggests a cosmic order of profound and shocking symmetry, where the universe as a whole possesses zero net energy, zero net charge, a perfect state of nothingness that has been cleaved in two to create the magnificent something we see all around us and its equally magnificent unseen partner. Anita's anomalous events, while deeply suggestive, are not yet the smoking gun. They are a profound clue, a tantalizing glimpse through a crack in the door. Other experiments like the Ice Cube Neutrino Observatory, buried deep within the Antarctic ice, have searched for similar signals, and so far found none deepening the mystery and fueling the debate. The scientific process is a slow, careful and often brutal one. Extraordinary claims require extraordinary evidence, and 2 or 3 strange signals from a single experiment do not constitute a proof, but they have ignited a firestorm of new research and speculation. They have forced us to confront the possibility that the universe is fundamentally different, grander and more mysterious than we ever dared to imagine. We are now actively searching for other corroborating signs, for new ways to test this incredible hypothesis. We are looking for faint specific signatures in the cosmic microwave background radiation, the afterglow of the Big Bang itself. We are hunting for gravitational waves, ripples in space-time, that might carry the imprint of a cosmic bounce rather than a singular explosion. The search has taken us from the realm of pure theory into the frozen heart of our own planet, and it has led us to the precipice of a revolution in our understanding. We are standing at a crossroads, staring at a set of data that makes no sense in the old framework, and a new framework that seems too fantastical to be true. But science has always progressed by embracing the fantastic. We have found a ghost in the ice, a whisper from a place that should not exist. And in pursuing this phantom, we may well be on the verge of discovering that we are not just children of the Big Bang, but children of a cosmic mirror. And if this mirror world is real, born of the same fire but flowing in the opposite temporal river, it leads to the ultimate haunting question. Does it too have its own stars, its own galaxies, its own life? Is there a consciousness, an anti-you, looking back at us across the infinite gulf of time, wondering if their universe is truly alone? And so our journey through the looking glass of creation brings us here to the very precipice of understanding. We stand before a cosmic mirror, one that has been slowly emerging from the fog of theory for decades, its surface polished not with silver and glass, but with the relentless pursuit of a single haunting question: why are we here at all? This entire odyssey began with a flaw, a subtle crack in the otherwise perfect symmetry of the Big Bang, a universe that should have been born with an equal measure of matter and its volatile twin antimatter. An initial state of pristine balance that by all rights should have annihilated itself in a sterile flash of light, leaving behind nothing but a cold, empty and silent cosmos. Yet we exist. Our galaxy, our sun, our planet and your own conscious mind are testaments to a profound violation, a primordial crime where one part in a billion of matter was mysteriously spared from destruction. For generations, this cosmic discrepancy was a source of deep frustration for physicists, a glaring error in the elegant mathematics of existence. It was a page torn from the universe's instruction manual, a dissonance in the symphony of creation. But what if this flaw was never a flaw at all? What if instead it was a signpost, a deliberate clue left behind in the embers of the first femtosecond? The paradigm we have explored together suggests precisely this. It reframes the problem of our existence not as an accident, but as a consequence of a far grander, more profound and almost terrifyingly perfect symmetry. The missing antimatter this theory proposes was never truly missing. It was merely sorted, pushed away, exiled into a parallel existence, a universe tethered to our own by the shared trauma of birth, yet utterly separate. An anti-universe governed by an inverted clock and populated by anti-stars, anti-galaxies, and perhaps anti-life. This is the staggering implication of CPT-Symmetry, the charge parity and time reversal, that when viewed on the grandest of all possible scales may hold true after all. The universe, it seems, does not tolerate imbalances. Instead of breaking its own rules, it may have simply created a second ledger, a cosmic shadow account where all the debts of existence are paid in full. Our universe, with its surplus of matter, is balanced by a ghostly twin that carries an equal and opposite surplus of antimatter. This is a concept that does more than just solve a nagging cosmological puzzle. It fundamentally rewires our relationship with reality itself. We have always considered our universe to be the entirety of the story, the alpha and the omega of what is real. From this new vantage point, however, our cosmos is revealed to be only half of a diptych, a single panel in a masterpiece of duality. Every particle, every force, every tick of our clocks might have a corresponding mirror image playing out a parallel drama in reverse. Think of what this means for time. We experience its passage as a relentless unidirectional arrow, a river carrying us from a fixed past toward an unknown future. This arrow physicists now suspect might be an illusion born of our local perspective. The entropy of our universe increases, systems move from order to disorder, and so we age. But in the mirror world, the arrow of time would point in the opposite direction. From its perspective, our future is its past, and our Big Bang is its Big Crunch. The two universes would be flowing away from their shared origin in opposite temporal directions, like two galaxies receding from each other, not just in space but in the very fabric of duration. It is a vision of the cosmos that is as philosophically unsettling as it is mathematically beautiful. It suggests that the totality of existence, the superstructure containing both our world and its reflection, is truly timeless. The beginning and the end may be two sides of the same coin, a single eternal moment of creation, viewed from opposing perspectives. Suddenly, the most fundamental constants of our reality feel fragile parochial. Is the distinction between left and right, so seemingly absolute to us, merely a local convention? In the mirror universe, the weak nuclear force would spin particles in the opposite direction, making a left-handed world into a right-handed one. Is the nature of positive and negative charge an arbitrary choice? There the antiproton would be the stable bedrock of their atomic nuclei, and the anti-electron would orbit it with a decidedly positive disposition. Everything we hold to be fundamental is cast as a coin flip, a 50-50 choice made at the dawn of time, with the other outcome playing out in a realm we can never touch, but whose presence we can feel in the subtle asymmetries of our own world. This hypothesis forces upon us a profound humility. We are no longer the sole proprietors of existence. We are perhaps inhabitants of one of two great cosmic kingdoms separated by an impenetrable wall. The grandeur of our visible universe with its 2 trillion galaxies and its septillions of stars is an astonishing spectacle. But to imagine an equally vast and complex reality, a perfect reflection of our own hidden just beyond the veil of perception, is to experience a kind of cosmic vertigo. It conjures an image of our universe as a single frame in a film, while its mirror image is the negative from which the print was made. Each contains the same information, the same intricate patterns of light and shadow, but expressed in an inverted form. And this unseen world is not a gentle passive echo. Its gravitational influence, faint but persistent, may be subtly shaping the evolution of our own cosmos. The mysterious pull of dark matter, that unseen cosmic scaffolding upon which our galaxies are built, might be the first tangible hint of this other side, the gravitational ghost of our twin, its hand reaching across the void to steady the spin of our Milky Way. The ongoing search for definitive proof is therefore one of the most ambitious and delicate endeavours in the history of science. It is a search for shadows, for whispers, for the faintest of gravitational ripples that might betray the presence of our neighbour. It's a quest carried out not with telescopes that see light, but with detectors that sense the almost imperceptible warping of space-time itself. Scientists are listening for the echoes of colliding neutron stars or black holes, hoping to find anomalies in the gravitational waves. They produce subtle distortions that cannot be explained by the matter we can see. They are hunting for the signature of a sterile neutrino, a hypothetical particle that might be our only possible messenger, a creature capable of flitting between the two realities, carrying secrets from the other side. Each experiment buried deep underground to escape the noise of our own world, or orbiting silently in the vacuum of space, is an ear pressed against the wall of reality, straining to hear the heartbeat in the adjacent room. Failure to find this evidence would not necessarily disprove the theory. It might simply mean the connection between our worlds is even more tenuous than we imagine, the mirror even more perfectly sealed. But every null result, every period of silence, only deepens the central mystery. If this grand symmetric model is not the answer, then we are forced back to the unsettling conclusion that our universe is fundamentally lopsided, its existence a product of a lucky, unexplained accident. For many physicists, such a prospect is anathema to the very spirit of their discipline, which has always been a search for deeper patterns, for hidden harmonies. The universe, they believe, does not play dice with its own creation, and so the search continues, driven by the conviction that symmetry is the universe's native language, and that we have only just begun to learn its grammar. This quest pushes the boundaries of our technology and our imagination, forcing us to build machines of unprecedented sensitivity and to dream of a cosmos more intricate than any mythology ever conceived. And what of us in all this? How does it feel to live in a world that may be only half of a whole? The idea of a mirror self, an anti-you, is the ultimate expression of this cosmic duality. Somewhere in a galaxy that is a perfect mirror image of the Milky Way on a planet that is a perfect reflection of Earth. A being composed of antimatter may be living out a life that is a perfect reversal of your own. When you make a choice, when you turn left instead of right, your mirror twin, bound by the inverted laws of their physics, may have no option but to turn right instead of left. It is an idea that borders on the mystical, blurring the line between physics and metaphysics. It raises questions about identity and free will that science may never be able to answer. Are we truly individuals, or are we two parts of a single symmetrical entity, forever linked and forever separated? Is our consciousness entirely our own, or is it one pole of a dipole eternally balanced by an anti-consciousness, experiencing the universe in reverse? This is no longer just the stuff of science fiction. It is a serious hypothesis born from the most rigorous mathematics. We have a potential solution to one of nature's deepest puzzles. It is a testament to the power of human curiosity, to our refusal to accept the world as it merely appears. We have followed a trail of breadcrumbs, a missing particle here, a subtle decay there, and it has led us to the threshold of a second creation. It reminds us that for all we have discovered, for all the nebulae we have catalogued, and all the equations we have solved, we are still infants in the cosmos. Our perception of reality is incomplete, like seeing only one side of a magnificent sculpture. We have spent centuries mapping the contours of the face we can see, without ever realizing that the true artistry may lie in its perfect symmetry, with the face hidden in the dark. Our odyssey must therefore end not with a comfortable conclusion, but with a profound and lingering uncertainty. The universe we thought we knew has dissolved into something far stranger, far more elegant, and infinitely more mysterious. We are left gazing into the darkness between the stars, but that darkness is no longer empty. It is now filled with a possibility of presence. The tantalizing, haunting idea that we're not alone in the most fundamental way imaginable. That our entire existence, every atom in our bodies, every thought in our minds is one half of a perfect cosmic reflection. Out there in the silent, inverted expanse of a universe we can never visit, our other halves may be looking back, asking the very same questions, completing a circle of cosmic consciousness that is as beautiful as it is vast. The proof remains elusive, a ghost we are chasing through the labyrinth of space-time, but the chase itself has changed us forever. It has taught us that the deepest truths about our existence may not be found by looking further out into space, but by looking deeper into the very nature of the mirror.